example number 3, we are given a vector in component form called vector A, and the value that they give us for vector A, 3, 5, represents the terminal point of our vector. So if we were to go to the origin of our xy coordinate plane and go right 3 and then up 5, the 3, 5 point is our terminal point. And the initial point is always on the origin when we are in standard form, which is the form that we're in when we're given a vector in component form. So initial point, we can see our change of x here is 3, our change in y here is 5. So therefore, we formed a right triangle, and we can find things like magnitude and direction using what we know about trig and what we know about Pythagorean theorem. So in this case, the magnitude is the length of that vector, and that's represented symbolically with a double absolute value bar. We take the square root of the leg squared, so 3 squared, the sum of the leg squared, so 3 squared plus 5 squared, which we see is 9 plus 25, the same answer as what we got above in example 2. And it makes sense because in example 2, we see that the length of this vector is equal in size to the length of this vector. So the magnitude of both of those vectors are the same. Now the direction is different in both these two vectors. To find direction, we want to think about the angle that's formed with the horizontal. So I'm going to switch colors here to purple. And a lot of the times with vector notation, and angle notation, we can call the angle x, but we oftentimes see it in physics and in higher level math as the symbol called theta. And I'll write that symbol a little bit bigger here. It looks like a 0 with a slash, a horizontal slash going through it, more like an oval or an O. And so when we think about the trig function that we would need to figure out that angle measure that's formed by the vector and the horizontal, which is the x-axis, we have the opposite and we have the adjacent. So thinking back to SOHCAHTOA, opposite and adjacent is my tangent. So I would say tangent of my angle measure, which is theta, is equal to opposite over adjacent, so 5/3. And then we take inverse tangent of both sides to solve for and isolate the angle. So inverse tangent. On our calculator, we would pull up the scientific calculator. I just had done it before, but to find it, you would go to function, inverse tangent, go back to the main screen, 5 divided by 3, and we get a measurement of 59 degrees. 59 degrees is the angle that's formed between the x-axis and that vector. So theta is equal to 59 degrees. That is our direction. Sometimes we're given, on the next two examples, coordinate points rather than the component form. So again, component form is with these funny brackets. It's nice because what we're doing is we're taking vectors that might not be in standard position and moving it such that the initial point gets moved to the origin. There's a really easy way to do that. So this initial point we're going to move to the origin. So the way that we do that is, let's call this vector the appropriate name. We would say that this vector, the initial point is C, the terminal point is E with an arrow on top. That's how you would name that vector. And in component form, we would find the change in x and find the change in y. So think of those as the calculations you normally do for slope. X1, Y1 is your initial point. So this is X1, Y1. This is X2, Y2. So you simply subtract the x values. 4 minus 1, subtract the y values. So here we have component form would be 4 minus 1 and 3 minus a negative 1. That yields 3, 4. So if you were to plot that coordinate point 3, 4 and connect the origin to that point, it's the same exact vector, but basically move such that the initial point is on the origin and then the terminal point is at 3, 4. And we can see it has the same direction, same magnitude as the original. So now written in component form for 2, we would apply the same idea. And we would say that the initial point, you find that where the dot is, that's your initial point. That's going to be x1, y1, and x2, y2 is your terminal point. Naming this vector, it must start with the initial point, end with a terminal point, with the half arrow on top. Component form here would be x2 minus x1, so 3 minus a negative 2, and negative 3 minus 2. So simplifying that, we get 5 comma negative 5. And once again, if I were to plot 5, negative 5 and connect it to the initial point, I would get a vector that is the same length as the original and the same, pointing in the same direction. Now, down below here, you're given 2 vectors, and we can see it's written in component form. It says draw the vector on the coordinate plane and then find the magnitude and direction of each vector. So just extra practice here. I'll do 3 with you guys to complete our examples. So for this one, we have 3 comma 4. So you go to your coordinate plane, you're going to plot 3, 4. So initial point at the origin, 3, 4 is your terminal point. Draw your vector pointing from initial to terminal point. And then to find the magnitude, remember magnitude is length of that, signified by the 2 double absolute value bar, square root of 3 squared plus 4 squared, or you guys should recognize that now as a Pythagorean triple, 3, 4, 5. 9 plus 16 is 25, or just 5. For the direction would always be tangent. We always use tangent for this. Tangent of the angle measure, which we can call x or theta. So let's say your angle measure is here. You would then say the angle measure is equal to opposite over hypotenuse, where your opposite leg is your y. So opposite, there's 4 and 3. So opposite over adjacent. And then inverse tangent both sides. And theta should be equal to inverse tangent of 4/3. And remember, anytime you're solving for an angle measure, you're going to use inverse tangent. So if we go to our calculator and enter in, and you can adjust this last one that we just did, and put 4/3 here, we get 53 degrees is the direction of that vector. So 53 degrees. So theta equals 53 degrees. Now in pink, I'm going to plot 5, 2. 5, 2 is the vector starting in component form, or the origin is the initial point. This is your terminal point. Find your magnitude of vector B. Use the proper notation. That would be the square root of a triangle that has a base of 5 squared plus a height of 2 squared. So if we simplify that, 25 plus 4, or radical 29. We can't simplify that any further. 29 is a prime number. And once again, we use tangent. Tangent of theta is equal to the opposite is 2. The adjacent is 5. Switch over to green again. Now, if I wanted to solve for theta, theta is equal to inverse tangent of 2/5. Inverse tangent of 2/5. So again, you can just adjust your fraction inside here. And we get 21.8. I don't believe it says how to round, but if it says to round to the nearest degrees, we would say 22 degrees. Approximately 22 degrees.